I'm here at the Laser World of Photonics at the booth of ID Quantique. It's always a pleasure to visit. We spoke to Mark in OFC and I'm here with Jeremie. Jeremie, tell us what's new at ID Quantique.
So hi John, I'm Jeremie, product manager at ID Quantique for the Quantum Detection Systems division. And what's new today is actually we want to showcase a collaboration we've done with Swabian Instruments.
Clio 2024, I'm at the booth of Swabian Instruments, understanding what they do at Clio 2024. Thomas Hayes, what did you bring to Clio?
Yeah, so we are here demonstrating our top-of-the-line time taggers. Really what we're doing is revolutionizing the industry. Now, how are we doing that? Well, at the moment, if you look here, we have our Time Tagger X. Lowest timing jitter on the market today, down to 1.5 picosecond jitter. That is record-breaking in terms of a commercially available TC-SPC system, but it's not our focal point. So what do we do best? We're taking the time tags and streaming them to a PC in real time. The beauty behind that, if you come a little closer, we have 7 different measurements running right now off the same time tag stream. A couple here on our laptop and a few more here on the monitor. And the beauty behind this is it's all live in real time. So if you take, standard counter, what we're measuring here is counts on a detector. You can see live as I run my measurements here, I'm blocking the laser and right away our counts drop. And the beauty behind doing this all in live in real time, so what are we solving for scientists? What we're doing is making it far easier to perform these experiments, minimizing the time you're spending coding and maximizing the time you're spending analyzing your data, advancing to the next research. That's really our goal. So to provide time tagging instrumentation that's going to make it far easier to analyze and get your measurements out and ultimately accelerate your research timelines.
What are the main challenges that you would like to solve in the coming years for this industry?
Probably what we'll focus on most is accommodating a wider user base by expanding on our software. The feedback we've received from existing customers is that we've been able to solve a number of measurement challenges, and the way we've been able to do that is by expanding on our existing measurement classes. And so what we hope to do in the coming years is tackle a number of different applications. So the timing and frequency domain primarily is really what we're focused on at the moment, and the hope is to bring additional value in terms of our time taggers to a much wider audience.
And what's new today is actually we want to showcase a collaboration we've done with Swabian Instruments. So both our scientific teams actually work together to build the best photon number resolution system that exists today, and that's super useful for quantum computers and specifically photonic quantum computing. What we've achieved by using our unique parallel SNSPD technology and the Swabian team is that with one detector and 2 coaxial cables, we were able to measure with extremely high fidelity up to 8 photons. And that's something that we believe is going to be a game changer for everyone who is building today a photonic quantum computer. So today we're showcasing our rack-mounted SNSPD system, which is capable of going up to 16 detectors. The idea is really to make something that is install and forget, so that you can operate it remotely and 24/7, so that we really answer the needs of the industry, specifically for secure locations, data centers, high-performance computers. And we've actually taken the liberty of adding a QKD, one of our own QKD racks on the top, because we know that there are some good benefits to having a QKD added to an SNSPD system, because we can actually either extend the range of the QKD distance that can be used, or actually increase the data rates.
Great. Are there any other applications other than photonic quantum computing useful for this, or is that the main?
So these kind of detectors are also useful for ultra-fast counting, which is excellent for if you want to do, for example, high-speed QKD and have extremely high key rates. This is definitely something that you want to look at. And that's where we believe that we have a good combination between our detector and our other activities, which is to generate QKD systems that are perfectly retrofitable for existing networks.
And it's always fantastic to showcase such a good collaboration. What can the Optica community do to help you with getting this out into the world?
So the Optica community is already helping. I mean, you're here today, and you actually give a lot of visibility and energy to what we do on a daily basis. And also through the conferences recently, actually in the United States, in North America, you guys were super active on this first half of the year, and we benefited from that by being present. Our VP of Technology, Félix Bussière, was also giving talks that you guys organized, and we've had great feedback from that.
Jeremie, thank you so much for showcasing this great collaboration with Swabian Instruments. We're going to come back to Munich in 2 years. What can we expect to see from ID Quantique?
We're expecting to have a lot more partnerships, because we know that alone you go faster, but together you go further. And this is what we believe in the quantum industry.
Thank you so much.